My name is Sweta Mishra and I am here to share my views on metric space and pseudo-metric space. So let's get started. For metric space, what is metric space? If we let X is a non-empty set, then a mapping D represented by D X into X, mapping from X into X to R is said to be metric for X if it satisfied following properties, for example, which are first property is dxy is greater than 0 for every xy belonging to X, which is also known as non-negative properties. And second property is dxy is equals to dyx for xy belonging to X, which is also known as symmetric property. And third property is dxy is equals to 0 if and only if x is equals to y. Here if and only if means that if x and y, if x is equals to y, then dxy is equals to 0, and if dxy is equals to 0, then x is equals to y, which that is it is a that is it is also a sufficient condition for X. Fourth property is dxy is less than equal to dxz plus dzy for every xyz belonging to X. And X is known as metric space for, then X is known as metric space for D, and it is denoted by X comma D. Let's continue with a question. Let X is equals to R and is the set of real number. Here R is the set of real number, and a mapping which is given as this and defined by dxy is equals to modulus of x minus y, then so that xd is a metric space. So we are given that that mapping x cross x, mapping we are given mapping from x cross x to R, and which is defined as dxy is equals to modulus of x minus y for every xy belonging to X. Then we have to show that xd is a metric space. For proving the first property, that is non-negative properties, let AB belong to X. Now DAB is equals to A minus B, which may, and since we know that when we open modulus, the value cannot be negative, so DAB is greater than 0. Second property is, for proving second property, let AB belong to X, DAB belongs to X, and DAB is equals to A minus B, and we have taken minus common. Minus will go outside and become outside of modulus and become plus, and we get B minus A, hence DAB is equals to DA minus DABA. Now third property, let AB belongs to X and DAB is equals to 0 if and only. So if DAB is equals to 0, which means here it will be, on solving this we will get A is equals to B, which means DAB is equals to 0 if and only if A is equals to B. Now for proving fourth property, let ABC belongs to X, DAB is equals to modulus of A minus B, and we will let A minus C plus C minus B, and we will take their modulus outside, and it is the property that modulus of A plus B is less than modulus of A plus modulus of B. So here we will take the negative sign, and on solving we will prove this triangular inequality. Hence x comma d is a metric space, and such type of metric space is known as usual metric space. Now pseudo metric. Let x comma b is a non-empty set and a mapping dx x into x, mapping which maps x into x to R and is said to be pseudo metric space if it satisfied following properties. See what is there, all the properties are same, but here is a slight change in pseudo metric, that in this third property where there was if and only if, there is only if. So here the thing changes is dxy, if dxy is 0 then it means x is equals to y, but if x is equals to y, it does not mean that dxy is equals to 0, which means this is only a, here it is only a necessary condition, but if we see back, it was necessary as well as sufficient condition. So if so all the except this one, all the other properties are same. So this and x, then x is known as pseudo metric space with respect to d. So here also let's talk about a question which is, let x is a non-empty set and a mapping which maps x into x to R is defined as dxy is equals to x square minus y square for every xy belonging to x, then so that D is pseudo metric space. So what we are given? We are given that there is a mapping from x cross x to R and it is defined as dxy is equals to modulus of x square minus y square for every xy belonging to x. So for proving first property, let xy belong to x. Now dxy is equals to modulus of x square minus y square. So it will be obviously greater than 0, which will imply that dxy is greater than 0. Now let xy, now let xy belong to x. So dxy is equals to modulus of x square minus y square. When we take minus common, we will get d modulus of y square minus x square, and since minus goes outside, it becomes plus. So dxy is equals to dyx. Second property is satisfied. Now we come to third property. dxy is equals to x square minus y square. Now we will use this property, x square minus y square is equals to x plus y, x minus y. So here we will use this property and we will get this, we will get dxy is equals to x plus y, x minus y. So if x is equals to y, then dxy is equals x minus modulus of x minus y is equals to 0, which implies that dxy is equals to 0. But if dxy is 0, it is not necessary that x is equals to y. Since dxy is 0, so this could be 0 and this could be positive. So if we will equate is equal to 0, so it won't be equal to each other. Hence, now fourth property, let xy, now fourth property, let x, y, z belong to x. Now dxy is equals to x square modulus of x square minus y square. Now we will add z square and minus subtract z square. Then again we will use this property, a plus b whole modulus is less than equal to modulus of b plus modulus of a, and here we will get inequality sign, and this will be equal to dxz plus dzy, and hence dxy is less than equal to dxz plus dxz plus dzy, hence d is pseudometric square.